Hello, everyone. Thank you for joining us. We'll be getting started in about 5 minutes. Okay, we'll be getting started in just about a minute, so please stand by. All right, I think we can get started. Hello, and thank you for joining us for another edition of the Unreal Engine webinar series. Again, I'm your host, Eddie Perlberg, and today I'm joined by my colleague, Paul Kind. Paul is a blueprint wizard, and it's a joy to have him on the enterprise team. Today, Paul is going to show us how to create an amazing product configurator using the Unreal Engine. So what are we going to cover? Well, Paul will show us how to control some of the cameras within the configurator, then give us some interactive controls for the background environment and bring it all together into a heads-up display. Now, before we get started, though, there are some housekeeping things that I want to remind you of. Portions of today's presentation have been pre-recorded. We appreciate that your time is valuable, so we want to present to you the highest quality webinar that we possibly can. Now, I can assure you that Paul and I are here answering your questions, chatting with you in the chat room. And speaking of the chat room, I see many of you have already discovered it and are conversing. Let's be sure to keep those respectable in conversation. Now, you'll also be presented with polls. Please fill those out as they show up in your interface. As far as questions are concerned, please use the question button. That'll bring it up into a different part of Paul and my interface so that we can give it the attention it deserves. And you do that by changing the chat button to the QA button and then writing in your message. So then that way we'll see it. Some of the questions we're going to actually answer during the Q&A sections of today's session. So don't be alarmed if we haven't answered it right away. It might be something that requires a little bit of explanation, extra explanation, or it may be something that we want to make sure the entire group sees. Now, for today's session, because it is of such a high technical nature, we're actually going to break up the session into 4 different parts with like about a 5-minute QA session in between. So we'll have a number of opportunities for you to ask your questions throughout. So we'll be doing that. And then after today's presentation, be sure to watch your email for the links to the survey, the replay, and the project that we're using today. So the replay, I strongly suggest that you go ahead and just sit back and enjoy today's webinar as we present it live, and then go back to the replay so that you can really digest it. So if you're trying to follow along, you'll get lost quickly. But if you go ahead and use the replay, send it to whomever you think would be benefiting from it. And then if you could promise to fill out the survey, that's where we get our ideas for what you're looking for from the webinar series. So that's, in fact, how we came up with today's topic and future topics down the road. Now, speaking of future topics, be sure to mark your calendar for the next session. It's going to be on Tuesday, June 26th. We're moving the Unreal Engine webinar series to Tuesdays, so be sure to watch that moving forward. Now, the next coming edition will have exciting news regarding the development of Datasmith, and we'll have special guests from Trimble. They are the makers of SketchUp. So I'm not sure what we'll be talking about, but I'm sure, well, I guess we do know what we'll be talking about. We'll have very exciting news for you, so be sure to mark your calendar if you're a SketchUp user, June 26th. So for those of you who are new to the webinar series, one of the most often asked questions that I get whenever I meet people going down this road is, why should I use the Unreal Engine? And the answer is, there are many, many compelling reasons why you should consider the Unreal Engine. Just a few are our legacy. With over 18 years as a premium award-winning real-time engine, we are production proven both in the gaming world and in the enterprise world. And speaking of enterprise, we have a worldwide team focused on the issues and complexities and the unique elements that bring the enterprise customer like us brings to a real-time environment. We are everywhere with over 3 million users worldwide. There is a plethora. I don't get to use that word often, but it's true here that there is a plethora of resources available to you, and we're free. Free versions include the entire tool set, all the source code you need for learning and creating, and as an Unreal Studio subscriber, you have a completely 100% royalty-free license for distribution. So you're completely covered when it comes to the Unreal Engine. Now, for those of you who are new to the Unreal Studio, it really allows you to achieve frictionless workflows with your designs. And you can find out more about it here at unrealengine.com/studio. In fact, that was the topic of our last webinar. So you can get the replay for that here. For those that are here live, I'll go ahead and post that in the chat notes. And for those of you who are watching on the replay, go ahead and pause me and write down the address. Well, what do you say? Let's get started. We have a lot to cover. I'm going to turn things over to Paul Kind, and he's going to show you all the great tools he's come up with for this particular speaker configurator for your inspiration and learning. So Paul, go ahead, take it away.
Thank you, Eddie, and hello everyone. Today we will be delving into a configurator project and investigating the inner workings of what makes one tick. We have been asked in previous webinars to go deeper into mechanics, so this part of the webinar is going to get a lot more technical than usual. I'll do my best to be clear and detailed, but because this is a rather complicated project, I'm not going to be going through every single detail. Because of the rather short nature of this webinar and the amount to cover, I would highly recommend downloading the project and trying to follow along as I go. Though this will not be a tutorial, I expect that being able to explore the project as I talk will be helpful. Today we will be picking 3 major features and examining the ideas and mechanics behind what makes each of them tick. By the end, I'm hoping to impart some ideas to help you spawn your own creative ideas. Okay, so as I mentioned, those 3 core mechanics will be: 1, we will examine a method for elegant and simple camera controls. 2, we will allow the user to have some control over the environment. And 3, we will display the product with different configurations. Hopefully, by seeing how these mechanics are constructed, plus a little time reviewing the project, you will be able to replicate the concepts in your own project. We'll get pretty technical, but more importantly, focus on the concepts, as a search should give you any of the node technicalities you may need. Now, let's go ahead and run the project and review how each part of our list gets resolved. Beginning with the configuration capabilities, we can see that by clicking each of the various elements of the speaker, we are able to make our desired selections. Another common and important feature is a HUD. Our HUD displays pricing and description information that is automatically being generated based on the user's speaker configuration. In order to allow non-developers to supply our product with its data, we will use spreadsheets and data tables to drive this information, along with some simple math and concatenations. Next, let's review the actions generated by the HUD. First, we have our volume and track selection inputs, which allow us some control over the soundscape. We also have environmental color controls, which adjust the color of the background. Lastly, we have camera controls, which will behave nicely even if the user does not. Okay, so now that we have reviewed the playing project, let's have a look under the hood, starting with the pieces at play. Take special note of where we can find them and their general purpose, so that later you can review them at your leisure. Level blueprint. Our level blueprint will mainly just instantiate our variables and set up the starting state of our project. It will also handle the camera controls via some functions. It is here where I plan to show you how to build a simple Boolean gate to control the user's input. Speaker blueprint. The speaker blueprint holds all of our various speaker meshes. As you can see, it is comprised of a number of individualized parts. Because they are individualized, we can receive clicks not only on the speaker blueprint as a whole, but also through the components. Notice, however, that the blueprint itself is relatively devoid of functionality, even though it is a major player in our project. This is because it is designed to be like a drone. It will be replicated and used, in our case, twice, but you can easily duplicate it as many times as you like, and they will all respond correctly. So, the job of the speaker blueprint is essentially to relay click events and also pass relevant model information to the speaker logic blueprint when asked. Speaker logic blueprint. The speaker logic blueprint is the brains of the operation. Though it does not contain models, it does contain the majority of our functions and handles all speaker interactions. It is from here that we will change speaker materials, calculate pricing information, concatenate descriptions, and tell the HUD what it should display. The HUD. The heads-up display plays a heavy role responsible for receiving input from itself and other blueprints. It also has to relay click events. Lastly, it is responsible for displaying information to the user. The background. It mostly just sits there and looks pretty. We will change its material color parameters, but no actual functions are held in the background. Cameras. The cameras are simply placed level objects. We will be cycling through them for our different viewpoints. Okay, so that introduces you to the major players in our project. You should now be able to locate them and, understanding their general purpose, be able to follow along or review meaningfully at a later time. Okay, so let's get started at the beginning. The level blueprint in this project is going to serve two purposes. Firstly, it will be the starting point for our logic and will initialize all of our other elements. Secondly, it will receive input from the HUD for camera movements. Because of this dual role, let's briefly review how things get started up. The first thing we do is create our HUD using the Create HUD node. This simply tells the level to create an instance of our HUD and adds it to the viewport. At this time, we will also store a reference to the HUD in a variable so we can access it elsewhere in our level blueprint. Next, we will go ahead and instantiate our speaker logic and our speaker blueprints. We start by using a getAllActorsOfClass node. This will search our scene and find every instance of the actor class speaker and put it into an array. Next, we grab our speaker logic and initialize it, passing it the array of speaker actor instances. We will also send a reference to the HUD. In effect, we are giving the phone number of our HUD and all the speaker instances to the speaker logic blueprint so it can call upon them at any time. Next, we initialize the speakers themselves, and a similar game is played. Here, however, our speakers are returned in an array. If you are unfamiliar with arrays, you can think of them as a list or something similar to a spreadsheet. We will need to loop through each of the speaker instances and individually instantiate them. Luckily, the for each node does just this, and conveniently loops through the array, returning our speaker instances consecutively. For every line of the array, we instantiate each speaker instance by passing them a reference to the speaker logic. The final result is that all of our speakers can call upon our speaker logic. When initializing the HUD, we do more of the same. We just initialize the HUD, passing it our background mesh reference and the speaker logic reference. Now our HUD can talk to the background mesh and the speaker logic blueprint. As we move down a bit, we can see that we initialize our view. For this project, we are using fixed camera positions, so we will simply set the view target to cam 1, using the set view target with blend. Next, we call the custom function setHUDCameraName, which we will be investigating shortly. Lastly, we set the variable total cameras equal to the length of our camera array. Using an array and a length like this is clever because you don't have to manage the variable if you add additional cameras. Instead, you just add the camera to your array and all the logic dynamically updates. This simple init event fires off simply to set our default background color and ensure sliders match the color. Okay, so that does it for initialization. At this point, what we have effectively done is created the foundation for a communication structure that looks something like this. You will see later how the functions are received, but mostly they just take the given input and store it as usable variables within their parent. Okay, I know that was a lot to absorb. Let's take a quick break and allow you to ask a few questions. We don't have a lot of time, so please keep your questions relevant to the material that was just presented.
Well, good morning and hello, everyone, or good afternoon. Thanks, Paul. That first part was excellent. I'm very inspired. So let's go ahead and see if we have any questions regarding that. So I'm here in the QA section. One question that I'm getting a lot of. Can you hear me okay, Bud?
I hear you fine.
Okay, I hear you as well. So one of the questions that I'm getting a lot is, how do I get the project? And again, like I said earlier, we're going to include that in the replay email. Hello. We're going to include that in the replay email, so you'll have links to all of this stuff. So thank you, Paul, for sharing that. I know it was a lot of work. So
yeah, my pleasure. I'm glad everyone gets to use it.
Look at all the glare I'm getting on my glasses.
Yeah.
All right. So looking at the questions, will we be sharing the project? Yes. And I already have the Unreal Studio replay in the sticky notes, so that's up there. Really, the project that we've included, and you can speak for this more, Paul, than I. Let me see if I can get these. Nope, that's just glary. The project is really for inspiration. There's no way you could teach all of this stuff in the time that we have allotted.
Yeah, it's kind of a big thing. Just a lot to go through in a short period of time.
So, I
think I go through most of it. I go through a good percentage of it. It's just you might have to digest it twice or three times.
Can you see the questions? Ganesh asks, so basically this project will showcase how to use arrays to store configuration data so it is more dynamic.
Yeah, we do that. We do some data tables so that, you know, if you have people working in spreadsheets and they want to submit data to your project, it'll use that system, which is really convenient if you have a lot of, you know, let's say you have people that are not tech savvy that need to have input on the project. They can hand you a spreadsheet that gives you all the data that might be like the description for the speakers or the description for the cabinets, whatever it may be, pricing information, all that stuff gets fed into data tables, which we import, and those act like kind of like an array. I mean, effectively they're an array, and I show that as well. So yeah, there's a lot of stuff in here just to make it possible to make a configurator from hopefully every angle that people need to make configurators from.
And then Dara asks, is there an easy way to add all the cameras to an array? Whoops. With one click rather than having to first create an array and then add each camera?
There might be, but I mean, it's so easy. I don't know. I've never looked for such a feature. There might be a feature that does that. I don't use it because I just create a music array and then just start adding the files to it. It takes not much time.
Okay, Ganesh gives us
the cameras. Adding the cameras is easy enough, and it allows you to select and order and organize. I go through that in a second.
And then one last one. Let's see. I'm here in chat now.
Just during development, Stefan.
Yeah. Is there necessary to split the logic and the speakers BPS? Can I implement the visual and the logic parts in one master BP blueprint, or is that ineffective?
Don't know exactly. I
I'm
mean,
not sure what we're
that's
asking.
what that's asking.
Well, actually, I
There's a
tell
lot
you
of
what.
different moving parts in this. It's not going to be something you can just import into a scene. You're gonna. It's more to figure out like how to build this kind of thing for yourself than to use it as a template, for example. I mean, you could. It's just you would have to have exactly the same type of want for your project to be a template. But it's more to show the concepts and ideas to like how do I switch materials? How do I get stuff like that working? How do I accept mouse clicks? How do I do those kinds of things?
Well, let's continue on with the webinar, and I think you'll answer some of these other questions coming up. So,
Yeah, I'll answer them in the chat dialogue.
all right, thanks. Here we go.
All right. Okay, let's jump back into the action. In the first part, we went through how the level blueprint is used for initializing all of our other logic. It also controls our cameras. In this part, we will take a look at some of the functions and mechanics of the cameras and their controls. It is common for imported scenes to already have cameras set up for a sequence of nice shots. For example, from 3ds Max via Datasmith, a designer may have set up approved views. This project mimics that scenario, while jazzing it up by transitioning from one camera to the next. This avoids the complexities of animating cameras, but does have some complications of its own. The biggest issue will be button control when blending from one camera to the next. Because of this, we will investigate a useful way to gate a function so it only fires when we allow it to, even if the user mashes a button repeatedly. Okay, so let's start with the setup. Looking at the level, we can see we have a bunch of cameras. It is helpful to name your cameras meaningfully. In my case, I chose Cam 1, Cam 2, etc. to give them a logical, sequential naming order. Inside the level blueprint, we can see that we store these names manually in a public array variable. This allows us to easily change the order, add, or remove cameras. Additionally, it makes it easier to select and switch cameras, as you can just ask for the line number of the array and it will return the corresponding camera reference. Okay, so now that we understand this setup, let's move into the logic. First, and during initialization, we do something a little tricky called binding. Here, we are binding the HUD function CameraNext to a custom event. This creates something similar to a relay. Once the custom event is initialized, it will then output an event when the button on the HUD is clicked. Notice that we do this with the previous button as well. Same thing, just a different button. Lastly, notice that during initialization, we will ensure our upcoming Boolean gate is open by setting allow camera click to be true. Okay, so now because of binding, our HUD sends a signal to fire an event from either of these outputs when the previous or next buttons are clicked. To differentiate the input within the function, we will use a Boolean variable to test if we are going to increase or decrease our camera number. If we click the up button, the variable camera up will be set to true. If the previous camera button is clicked, camera up will be false. So to recap, we have opened the gate by setting allow camera click to be true, and we know which button was pressed because camera up is either true or false. Following either path, we'll then call the function changeCamera. To review this function's actions, let's go ahead and open it. The first order of business will be to check if this function should run at all. Here, it simply checks allow camera click for truth. Remember, during initialization we opened this gate, so the first time we can always get through. However, if it fails, it will terminate the function by doing nothing further but playing a click failed sound. If it passes, we will immediately set allow camera click to false and prevent further clicks. We also play a confirm sound, letting the user know they have made a successful click. Okay, so what we have done is create a simple gate which automatically locks after we go through it. In this case, we are disabling the button so users mashing the next or previous button don't get undesired results. Once you sort of get the idea of building gates like these, you will find innumerable uses for them. In my opinion, they are a fundamental concept in blueprint work. Anyhow, next we will check the variable camera up for truth. This is where we will be doing the math to increase or decrease our camera based on the previous or next button being clicked. If it is true, then we will add 1 to the camera number. If it is false, then we will subtract 1. In order to control the looping when adding past the total camera number, we simply compare the values. If we go over the total camera number, then we set camNum to 0. This creates a simple counting loop based on the total number of cameras. It'll go something like 0, 1, 2, 0, 1, 2, 0, 1, 2, etc. When subtracting, we do the exact same thing, but in reverse. If less than or equal to 0, set camNum to equal the total number of cameras. The -1 node is used simply to align the count. Either way, next or previous, we will call the function goToCamera and relay our camera number. In the goToCamera function, we store our camera number to a local variable called camNum. Then we call the function setHUDCameraName and pass it the camNum. Without delving too deeply, this function simply tells the HUD the camera name to display. It uses this supplied camera number and checks against something called a data table for the display name. It then forwards that name off to the HUD to let users know which camera was selected. Okay, so finally we will switch our camera using the setViewTargetWithBlend. Notice how we use myCamNum and the camera array with the get node. This get will provide us the camera on whichever line myCamNum requests. These two public variables, cameraBlendTime and cameraBlendExponent, are simply used to adjust timings and smoothness. Okay, so at this point our camera is changed and there are no more executions to follow. However, we have not yet reopened our gate, allowing us to click again. Our variable, allowCameraClick, is still false. Delays can only be used in event graphs. So in the Level Blueprints event graph, we will see how it resolves. As we can see, after the change camera function call, we perform this delay operation. It is simply a delay set to the duration of whatever we set the default to in cameraBlendTime. When the time delay runs out, we set allowCameraClick to true. Because we used cameraBlendTime as our variable for the actual blend time from camera to camera, they are effectively synchronous. When the camera stops moving, we change it from false to true. So when the timer runs out, the gate is opened and we will await the next click. Awesome, so that's it for camera controls. Let's quickly review the playing project. As you can see, we can navigate through all of our cameras. Clicking Next gives me the next camera on our list, while clicking Previous goes backwards through our list. And if I mash the buttons, I get a bad click sound. Okay, I think that'll wrap up cameras. You know, this section wasn't as long time-wise, but we covered a lot of ground. Let's take a quick Q&A break before moving into part 3. Again, please keep questions relevant to the material I just discussed. We don't really have a lot of time to wander around.
That is true. And again, we are doing this so that so that we are inspiring you, and we'll give you a download to the project so you can dissect it a little bit. Any comments, Paul? I'm not hearing you. Is your microphone on?
I clicked it, but it didn't go. Sorry about that.
No worries.
Yeah, I've been mostly just trying to keep up with the questions. They're starting to get a little more technical, so a little more thought has to go into answering them. Yeah. Just trying to keep up.
Adrian asks, "Is it, Rhinoceros is an amazing Nope, it's moving. It's an amazing software program, but when you move it into other softwares, let's just say that that other software kind of messes up the UVs.
Yeah, so I answered that a little bit. UVs are, I mean, everybody has their preference, and I don't want to say what tool to use, but for
Absolutely
me,
not.
I'm a Maya guy at the end of the day, and I find Maya to be the absolute best unwrapping tool out there. So for almost all cases, I actually use Maya LT just because it's real lightweight, launches quickly, and the UV tools are the same as Maya. So yeah, I like Maya LT just for unwrapping, and I often will bring things into Maya LT just to unwrap them and send them to game engines.
And I do the same in 3ds Max. So, but you know, perhaps I don't know if you guys know, but Rhino is one of the supported file formats through Datasmith. So it, you know what I mean. I don't know what you're doing in your other DCC package from Rhino, but you know, if you're just moving it in there for transition, you don't have to do that anymore.
Yeah, you don't even have to export to an FBX, right? You just
Right.
send it through Datasmith and you're done.
Done. Why don't you go ahead and grab Emmanuel's how does Camera Blends actually manage the seamless transition between cameras?
So it takes 2 points and does a lerp. So it's just basically doing a linear interpolation from one camera to the next camera. It doesn't really have any kind of animated paths. It's just saying, I know the position of this camera. I know the position of that camera. I know all the settings of both those cameras. So field of view, all those settings just blend from one camera over to the other camera. There's really nothing to do there. It's actually built all into the function. The only thing you do have to be a little careful of is that if the cameras are not placed in kind of a good order, they literally just lerp from one camera to the next. So if there's stuff in between, you're going to fly right through them. So you're going to want to kind of arrange your cameras a little more carefully than you know, just willy-nilly, because otherwise you're going to have cameras flying through things. So generally what I do is I try to go around the object rather than trying to kind of crisscross, because then you have a much higher chance of, you know, pushing the camera through the object. And also another thing is, like, you don't want to have too dramatic of a turn, because it's, like I said, it's a lerp, and it may decide, you know what, I'm going to go to the left instead of to the right. It doesn't really, it's not super smart. It's kind of, it's really simplistic, but it's really useful because it's simplistic. So if you just put a little thought into it, it works awesome.
So I'm, you know, sorry about this, but we only have time for maybe one more question. So one at the top, can the cameras which are animated in 3ds Max be exported into UE4 as it is?
They can be imported, yes. Their animations will not be imported, as far as I know. You would have to do that animation work probably. And I guess if you put, you know, bone structure in it and animate it that way, maybe. But
let's get back to that one. I think that much of the, you know, I think you're right, but we'll go ahead and take a check on how much comes over, especially using Datasmith. To be honest with you,
I don't believe animations are carried, but I'll double check that.
Yeah. So having said that, I hope you guys are enjoying. I hope you guys are getting a lot of inspiration. Thank you again for filling out the polls, and we're going to get back to it. Let's do it right now. Here we go.
Awesome. Okay, let's dive back in. At this point, we have heard a lot about the HUD, but we have yet to really see how it calls functions. In this section, we will walk through some of that process. In almost every configurator I have seen, some kind of control over the environment is expected. Here, I will show you the basic ideas with focus on changing background textures and sounds from the HUD. Let's get started by taking a look at the HUD, and let's navigate there now. Okay, here in the HUD, we can see I have designed a rather simple but elegant UI. Towards the bottom, we can see we have some sliders and some buttons to control the background color. These sliders let the user finally control the color, while the buttons select predefined colors. If we select one of the preset colors, we can see towards the bottom of the properties, we have an on-click event. This will be the event that fires when the button is clicked. Clicking on the view will take us to that event. Let's click it and see where it leads. As we can see, we are now in the event graph for the HUD. This is where we will receive events emanating from the HUD. Looking around a bit, we will see we have a lot of events doing things. Basically, one event for each interactive element we have, like our buttons. Okay, so once our button is clicked, its event will fire. From here, we will simply set the red, green, and blue variables to the values we want our color to be. Notice how for each of our preset buttons, we do the same thing while simply changing the values. Anyhow, once we set our color values, we will call the function playClicked. As we can see in the function, this will simply notify the user that they have made a selection by playing a successful clicked sound. Back in the event graph, we will then fire off the function setBackgroundColor. This is where we will actually tell our background color to change its material color. Notice how we have pushed the red, green, and blue variables as inputs into the function. Opening the function setBackgroundColor, we can see that this process is fairly straightforward. All we do is take our color inputs, slam them into a vector 3, and use the UE4 function setVectorParameterValue as materials. Now, you may notice that our function also requires a mesh reference. As you can see here, we are calling a variable called backgroundMeshReference. If you remember in part 1, inside our level blueprint, we fed this data to the HUD by calling a function called initializeHUD. Let's sidetrack for a moment, and let's take a look at what initializeHUD did for us. Notice that all we did was pass off the incoming reference variable to the HUD's internal variable, backgroundMeshReference. This allows us to access the background mesh reference whenever we want. Take note that we also stored the speaker logic reference here as well. It will be important to us soon enough. Okay, so returning to the track, in our setBackgroundColor function, we will simply use that reference here to feed the mesh reference for our setVectorParameter function. We will also pass it the required color values, as well as tell it which vector parameter to adjust in the material. Okay, so that basically does it for background colors. There is an additional function that we will run after setBackgroundColor, which tries to ensure that the tooltips remain legible no matter which background color you select. But let's call that out of scope for this webinar due to time. Feel free to review on your own though. Lastly, and before we move on to the sound control, let's just take a quick look at how similar the sliders are. Effectively, they are doing the same thing as the presets, only here we are driving the variables independently based on where the slider is located. As you can see, we call exactly the same chain of events when any slider is adjusted. Pretty cool, huh? Okay, so let's move on to the sounds now. If we look a bit further down in the event graph of our HUD, we can find the track selection controls. Here we can see that we have 4 button events relating to specified tasks. Here, we simply set an integer variable based on the selection made. For example, clicking the button for track 1 will set the variable audio track to 0. The second will set it to 1, etc. No matter which button we press, however, we will be funneled into the speaker logic function playAudio. As you can see, we are using the initialization variable speakerLogicReference I mentioned a few moments ago. Notice that we are also passing it the audio track. Because this function's target is the speaker logic reference, we'll need to jump over to the speaker logic blueprint to track this down. So let's jump into our speaker logic blueprint to see what happens next. Okay, here in the playAudio function of our speaker logic blueprint, the first thing we will do is pass the track selection we passed into our function to a variable. We will then perform a sequence of small tasks. First, we will stop the currently playing audio track by stopping whatever sound is playing in the music component. The music component is simply a sound component inside our speaker logic. Think of it as a single track audio player. Next, we need to queue up the audio track. To do this, we will use another get node with a music array, using the index to select it. Then we simply tell the audio component to cue the selected track. We use an array once again to make our selection list easy to manipulate. As we can see by clicking on the array reference, the contents are simply a list of 4 audio track references. These selected tracks are just references to imported WAV files. Due to sharing rights, the project you downloaded won't have the same music as mine. Instead, shareable placeholders were used. If you wish to change them, go right ahead and load up whatever music you like. Just import any WAV file you like to your project, and then replace one of the tracks in the array. Moving on, we see that we are just telling the audio component to play. Since we just set the audio track, it will now be playing our selected track. Last, all we do is ensure it is playing at the appropriate volume. To do this, we just pipe in the variable audio volume and use it to set the component's volume. If you are curious about the volume controls, I would suggest poking around the HUD a little and tracking it down. It's pretty straightforward, and using what you learned in this webinar so far, it should be easy enough to figure out. Alright, so we just marathoned through 2 HUD functions. Let's take another quick break. We're getting super low on time, so please keep the questions focused and on topic.
So here we are back again. You know, a lot of great questions, a lot of great comments. Anything we want to cover, Paul, at this time?
Not that I can think of. I'm just going to look through questions, see if there's anything that I haven't answered yet.
Okay. You know, I really, while you're looking through, I just wanted to take a moment and talk about, for those of you who are using the Unreal Engine and want to kind of show it off, put it up against others, be sure to check out CG Architect. They are currently running a contest with an Unreal Engine component, so you can go ahead and submit yours to that. You know, so that's something you can consider. Also, I want to take a moment to thank Paul before we get too far in here. You've really done a really, I can tell that you've taken some time to lay this all out so that, you know, as we look at it, it really makes a lot of sense. So thanks again for that as well. So
yeah, I always try to write my blueprints where if I have to come back to it in 5 years, I know exactly what I'm looking at, because there's no way I'm going to remember. And the only way you can really do that is by very logically organizing your blueprint layout and commenting. So hopefully that'll be easy for you guys too, that when you're looking this over, that you can kind of follow it almost just from the comments. I mean, if you have a little bit of background in Unreal, you'll probably have no sweat at all just reading it and being like, oh, okay, I get it.
So, so I'm gonna, if there's nothing kind of burning or pressing at this point, shall we move on?
Yeah, we can move on. I'll answer whatever I see in the chat. I'm trying to get to them all. Forgive me if I don't get to you, though. If I don't, just repost.
And don't forget, everyone, all of this stuff is captured for you. So we always go through the list of all the comments and questions. And if there's anything we missed during it, we'll try to catch you later on. So that's why it's always important for you to give us a good email address and a way to get in touch with you. So part 4, ready?
Let's rock and roll. Okay, so hopefully everyone is keeping up with me, or at least realizing how dynamic and powerful Unreal Engine 4 can be with a little understanding of Blueprint. Remember, just a few years ago, this would have been impossible without somewhat heavy programming. Anyhow, for this last bit, we are going to run through a practical example of material swapping on an object. Like we may have in a production environment, this model has multiple meshes and multiple materials corresponding to its various parts. In this bit, we will explore just how it was handled. Let's go on ahead and dig in. To begin, let's start with the speaker blueprint. As we can see, this blueprint has all the meshes required to assemble our speaker. Just selecting around, I can see that all my parts are individualized elements. Because of this, I am able to receive clicks on them. If we jump into the speaker blueprint's event graph, we can see this. For each of my elements, I have an on-clicked event, allowing me to receive those clicks. Pretty cool, huh? From there, we will simply group the parts according to their likeness. For example, clicking on the feet, cover frame, or accent plate should trigger an accent change. Next, we will go ahead and fire off our clicked function. Now remember, these speakers are acting kind of like drones. We don't want to change the accent material on this speaker. We want to change the accent material on all the speakers. Because of this, we will relay our event onto the speaker logic. Okay, so let's track it down. To do that, we need to head over to our speaker logic again. Okay, so here we are in the accent clicked function within the speaker logic blueprint. Now, when we click on the element of the speaker, we want to sequentially run through the options for that element. Therefore, we need a way to serialize and store our current selection. We will do that with this little node group by effectively just counting the clicks. Basically, we start with our accent index default being 0. We then add 1 to it. We then use the modulus of the maximum index. This effectively makes a simple counter that loops when it hits a max number. It'll do something like 0, 1, 2, 0, 1, 2, 0, 1, 2, etc. In our case, the loop is set to 5. As we can see, if we check the default value of the index max. Okay, so now that we have a simple counter, we will immediately use that counter to select which path to travel. Here you can see the accent index being put to work with a switch on int node. This will simply route us based on the accent index. As you can see, we then call the function setAccentMaterial, which takes the input of the accent material and the foot accent material. For each of our routes, we simply change this input to suit our selection. Effectively, we are simply queuing up which material to use based on our accent index. Now, let's go ahead and take a look at what happens inside our setAccentMaterial function. Okay, so remember, we kicked this off to our speaker logic so it could process all the speakers in our scene. Here is where we will get some of that magic to happen. Since the first thing we did was store our incoming material selection variables locally, we already know which materials to use in the swap. What we don't know is where to apply these materials. To do this, we will need a list of speaker actors we have in the scene. Luckily, we stored that in an array called speaker actors in part 1 during initialization. Now, all we do is call that here and do a for each loop on its contents. This will sequentially process each speaker. At this point, we know the materials we want to swap, we have a list of speakers, and are processing them individually. Now, we will ask each speaker in the array for their list of accent meshes with the function getAccentComponents. Let's go ahead and jump to that now. Note that this function is stored in the speaker blueprint. As we can see, this function simply returns 2 mesh arrays. Those mesh arrays are constructed with the makeArray node. All we do here is pipe in the appropriate meshes for our 2 materials, one which handles the feet, one for the rest of the accents. Okay, so now we have our mesh arrays and are returning them when the function is called. Cool. Let's hop back into our setAccentMaterial function in the speaker logic blueprint again. Now, because our getAccentComponents function returned us arrays, we need to do another for each loop. This time, it loops through all the meshes of a specific speaker and applies the material to each of those meshes. Notice we do the same operation on the foot meshes as well. Okay, so our materials are now swapped. Hooray! I know you probably feel like you are trapped in the movie Inception with all the loops within loops, but the concept is easy enough. We select a set of materials, find all the speakers in our scene, ask them for which meshes to change, then specify the material change. The reason it may feel a little complicated is just because of the arrays. Just keep in mind, the for each loop just cycles through individual objects. The output is always just a series of singular elements. Alright, so the material is changed, but we still have more to do. For example, the HUD has not yet been notified of this change. Back in our asset clicked function, after we do the material swap, we fire off another function called calculate accent pricing. Let's go ahead and track it down and see what it does. Because we will often want to have external non-technical people edit and organize data for us, it can be helpful to use spreadsheets. Here, we will do just that using Unreal Engine's data tables. If we take a quick look in our project content data reader folder, we can review our accent data tables. Opening it, we can see that it very much resembles a spreadsheet. Storing our short description, long description, and price, we can use this to easily obtain our required information about a given entry. Back in our speaker logic blueprint, we do just this. First, we will convert our index integer to a string, then to a row name. Then we simply look up the row name of the accent table. Basically, we are just saying find row 1, find row 2, etc. This, however, does not give us the entry. Just the line. We will use the break structure node for that instead. This allows us to get the results from any cell of our spreadsheet's denoted line. We then just pipe that data into variables, which we will use when calculating the final price. Okay, so we have changed the materials and stored the data for the HUD. Now all we have to do is output the data to the HUD. That is the job of the calculate final price function. Let's go ahead and go there now. This function is responsible for reporting our changes to the HUD. To do this, we will need to fill in several key areas with data. The short description, the long description, individualized pricing, and the total price. As you can see, I have them neatly organized into separate node groups. Let's begin at the top. Calculating the total is pretty easy. Just add together the totals of all the prices, send it off to the HUD. Nothing crazy here. Next, we will submit each of those prices individually into the HUD. Again, nothing complicated, basically just setting variables inside the HUD. The short descriptions will also get sent along to the HUD. Same thing, just different type of data. Instead of pricing, we are submitting the descriptive name. Last, we go ahead and do something a tad clever by way of concatenating content. Here you can see I am taking the long descriptions of all the different parts selected, like cabinet choice, speaker choice, etc., and crafting sentences from them. It looks a bit complicated, but it's really just concatenating content to form sentences. It looks really nice on the front end to have unique descriptions, but it alleviates you from having to create each and every possible combination. Once the concatenated sentence is complete, we just submit it to the HUD like all the rest. Okay, so our HUD is updated, our materials are changed. I think we're done here. I think that might be the most amount of content I've ever thrown at an audience in such a short period of time. I do hope I didn't lose anyone in the process. Okay, let's stick around for one more question and answer session, and feel free to plug me on anything you still don't understand. Oh yeah, thank you. It has been a great pleasure and honor to speak with you guys today. Thanks a lot.
There you go. So again, we appreciate, and thanks again, Paul. We appreciate that this is a lot of information in a very short period of time. And so, you know, don't, again, we will be sending out links to the project very shortly after the webinar is over this morning, so you can download it, dissect it, be inspired by it. And again, thanks, Paul, for making all of that. I'm kind of thinking that maybe we might make this a little bit of a broader topic in the future, or maybe dissect it a little bit differently. Before we go back to the questions, two more things about, regarding housekeeping. I commented about the CG Architects CG Award. So here you can see you have about a month in order to get your submission in. And right down here is the Unreal Studio Studio Experience category. So one of Unreal is the fastest growing category in this in design visualization. So thank you guys for that. In the poll, second topic, in the poll, I asked if you guys have taken advantage of the training that we are providing as a part of Unreal Studio. I wanted to show you that page. Another poll asked, why are you struggling with Unreal? And a good number of you, not all of you, but a good number of you said, I don't know how to prepare my data. Well, as you can see right here, there's a class that is designed specifically for that. So the video tutorials are here under unrealengine.com. Go to resources, video tutorials. So currently these are available to you, and these are complete. So I can't begin to tell you, with all the experience that I've had with Unreal moving forward, how much I've learned from some of the mastery in here. So you can see that the topics are varied. The topics are from beginner level to advanced level. So, and then some of the things that Paul showed in today are here, like material swaps and heads-up displays and things like that. So, so again, for those of you who haven't found this, unrealengine.com video tutorials. So that's, let me get out of here. So I just wanted to point those out before we go back to any questions. So having said that, Paul, I'm going to turn it over to you, whatever you'd like to wrap up here.
Sure.
In these last
so I just was looking at one of the questions that Nicholas Esposito had mentioned. He says, since you have the models in a single BO, I'm assuming he's saying BP or blueprint, I guess you're swapping the models on the fly with real-time lighting. The answer is no, it's all baked. There may be one or two real-time lights, but I usually bake everything, so probably it's baked. And all we're doing is swapping out the material. So we're not actually doing a model swap in any way, shape, or form. We are just swapping the material. So that's actually kind of the whole beauty of the way it was built, is that it's extremely clean in that regard. Most of the time, I mean, you could do model swapping, but this doesn't actually do any model swapping. It's just materials. So pretty straightforward on that one. And actually, the last part, that's what we're going to get into entirely. So
there's more.
Oh, are we on part 4 already?
Yeah, it went fast.
So yeah, and that should have been answered for you, because there's no model swapping.
Okay. Again, while Paul comes up with his next question, again, I'm going to remind you, project files are the link will be in the follow-up email. Somebody asked about the questions and answers in the replay. Unfortunately, I don't have a way of capturing all of that, but it will give you a chance to pause the video, check out, maybe zoom in, those kinds of things, so that you can kind of get and then you'll have the project on one side, the video on the other side, and you can really dissect side by side, so you can get a good, get a good, yeah. So
I have one more question I'd like to answer in this form, if that's
sure.
Cool.
Sure.
I have a question by Dave, and forgive me if I butcher your name, Bukov.
Yeah,
I'm assuming that's correct.
That's how I pronounce it.
And he says, "Oh wait, yeah, okay. So will you have a live stream covering covering meshes themselves?" So this is similar to the question that was just asked, like switching the speaker meshes or even character customization. So if you look at the blueprint for the speaker, you'll actually notice that it is the same blueprint, whether it has the face cover on or not. So like the protective screen is turned on and off. So you could actually look at that and see how I'm doing it, because that would be the same as kind of like attached parts, or I don't want to say model swapping because we're not doing model swapping, but we are enabling and disabling certain features within the model. And though that's just like a kind of a preset variable that you use inside of it, you could switch that on the fly, and that could be easily turned into like, I want to turn it on or I want to turn it off, or if I select this item, that it will, I don't know, put the cover on or take it off, or give, anything like that. You could do anything like that. I'm trying to think of a good example, but like I hate to use a gun reference, but like a gun, and then you have a silencer. If you want the silencer put onto it, you could just, have that as a switch that you can trigger or not. Very straightforward, using the same exact mechanics. Just you need a variable and switch it in code.
I'm going to go back to Dan Barker's question. You've kind of already answered it, but he just kind of asked, for those that didn't see it, how long did it take us to develop this? You know what I mean? How long should an average person set aside to creating something like this?
I mean, that's going to be very different for everyone in their journey along the process. For me, I mean, I found it to be really easy to do. I did it in about 3 days, and that was including all the modeling, all the lighting, everything. Like start to finish, it was 3 days, and then I just wanted to add some like creature features that would kind of like, I don't know if you noticed, but like I don't allow the multiple clicks. Originally, I could click through them all. So that was not done in the 3 days. And then I was like, all right, I want to clean that up. And then I think I put another couple days into it. So a week is a fair amount of time for an experienced person. But again, that's with, I've got years of experience. So for someone who does not have years of experience, you gotta pace yourself based on what you're capable of doing and what you can get done for yourself. I mean, there's no correct answer for that, is I guess what I'm saying.
It really, it's one of the most often asked questions I always get throughout the course of my visualization and product career is, how long is it going to take me to learn this? How long is it going to take me to get this done? How, what I mean? How long is it going to take to, and really the variables that are a part of that question are too numerous to give you even a ballpark. So the answer I always give is, it's like learning to play the guitar. If you want to learn a song, it could probably take you about 10 minutes to learn a song on the guitar. If you want to play at at the Sydney Opera House, well, then you're going to probably it's going to take a little bit longer to learn. So, and that's why we're really focused on learning and sharing these kinds of things at Unreal, so that you can get a kind of a jump start and get really the the benefits of experts like Paul to kind of guide you along the way and show you the best practices.
So there was one question that I've seen asked by a few people, and the most recent by Florent Germain, and you're asking about a web product. So I actually output this originally for WebGL, and it ran fine. A little bit of a loading time, but nothing bad. I mean, with the speed of internet these days, if you make it low enough, if you keep your textures smaller and you make your packages a little more, I guess, data non-consuming, you can definitely go to the web with it. You definitely will want to consider lighting a little differently, because the lighting scenario inside WebGL is not nearly as robust as it is in an engine. But a little testing and a little tweaking, and you can make it so that no problem is the answer, no problem. So for a configure, that's actually one of the most common uses for a configurator is on the web. I want to buy this drill. Well, what does it come with? What does it look like? All the stuff that it can do. So yeah, you want to have WebGL capability, and it totally is easy. Like, you can take this project right now and export it for WebGL, and run it, and it'll run. I mean, it won't look very good because the lighting isn't catered to, but you could totally do it, tweak the lighting, and get it working. This project has very high resolution textures, so it's a little slower to load. But like I said, those are just considerations, and you can manage around those considerations easily and get WebGL support absolutely out of the box. So I hope that answers your question.
Stefan asks, I mentioned sticky notes earlier when talking about other webinar links. That's right at the top of the chat. The list of links, Stefan, is getting really long, so I can't fit them all in there. So I'm just going to do the last one, and then I'm going to talk to the webinar group. There's perhaps a way to send out, hey, the webinars that you missed replays and things like that. And then Dan Abrams, asks, can I link things like a sofa and a wall and a chair so that all of that changes, with one click of a button? And absolutely, you know what I mean? That's simply linking multiple inputs to a single. So that's,
yeah, we're already doing that in a way. I mean, it's a different thing because it's all one speaker. But you could think of the speaker as a living room. I mean, that's just a conceptual thing at that point. You could make it so that, when you click on the couch, what happens? Okay, so it sends a signal. Again, you're going to want some sort of external logic node, like I did. Like I have the speaker logic as a separate blueprint that handles the functions for the scene. So you would want to do something like that as well. But totally, yeah. I mean, conceptually, it's exactly the same thing. It's just, you got to kind of like wrap your mind around the fact that, okay, the speaker is really the same concept as a living room, right? I mean, it's not in our mind, but on a computer, it's all the same. It's just a bunch of objects that are contained in a blueprint.
Yeah, actors are actors in Unreal. So static meshes are static meshes, whether it's a speaker case or a couch.
Yeah.
Nicholas Maybach, is the configurator possible in VR? Absolutely.
Sure.
So what you would do is on your controls, you can have a menu that you point at and click, or you can actually put it on the thumb controls for the background colors. You could switch between the possibilities are really endless for that. So you could be as creative as possible. And that kind of answers up, something going back to that, that question about chairs and sofas. What we're really trying to accomplish with Datasmith and Unreal Studio is the ability to, and somebody asked about how long should I allocate for each one of those things. And it used to be, you would have to spend, if you had 100% of your time, there was probably about 50% of the time that you would have to use for cleaning up the data coming in from your CAD package, your DCC package, and things like that. And that would only leave you 50% of your time for the creative. What we're really trying to accomplish with Datasmith and Unreal Studio is we've dramatically reduced that 50% cleanup time and importing time down to maybe like 10%. It's not, you know what I mean? There'll always be little things that you'll want to be able to control. But what that'll leave you now is, rather than just 50% of your time on a project, for the creative, you have now 90% of the time for creative. So hopefully that answers that question. So I tell you what, we're kind of a little long on time here, and I appreciate you guys hanging out. I really know that your time is valuable. What we're going to do is we're going to wrap things up, but we'll leave the chat open for a little bit, and Paul and I will continue to answer your questions for another 10 minutes or so. But at this point, let's say thank you very much for your time. Again, mark your calendars for June 26th. That's going to be our next webinar in the series. And Paul, any final words?
Not that I can think of.
You guys, Paul has put a lot of effort into this, and I have to again say thank you very much for all of your time, Paul. It turned out great. So thanks everyone, and have a good night.
Thanks a lot, guys. This was awesome.